I want to discuss an important math skill in this chapter, which is calculating the percent composition of a particular element, such as carbon, in a molecule or a compound. And the reason this is important is connected to that calculation of heat content that we had discussed previously. If you know how much carbon you have or how much hydrogen you have, then a lot of times that tells you the relative amount of energy that could be generated by that particular fuel. So the general way you can calculate percent composition is these two listed here. The first one is using molar masses, which is a number that you can find in the periodic table. If I want to know percent of element A in compound AB, all I need to figure out is how many moles of A I have in the formula times the molar mass of A divided by the molar mass of AB multiplied by 100%. I can also find percent composition using measured masses. Be aware that that is different than molar masses. Measured masses means I would take the compound, let's say CD, and I would decompose it. So I would break it apart at high heat. The product of the decomposition is the individual elements that are found in the compound, so C and D, and I would weigh the mass of each of those elements. And once I have those masses, I can calculate the percent composition this way. I would take mass of the element C that I have divided by the mass of the compound, which is CD. Okay. A third way is if you want to calculate the percentage of a compound in a mixture. As we talked about earlier with something like petroleum, it has a number of different compounds, all the different methanes, right? From the really tiny ones all the way to something containing 70 carbons in it. So if you want to know, for example, how much methane a sample of petroleum has, you can calculate it this way. So let's say you're interested in compound F here in this mixture. You would just take the mass of F divided by the mass of the entire mixture multiplied by 100%. So I want to go through a couple of the calculation of percent composition that we just discussed. The first question asks for percent carbon in the following carbon-containing compounds, CO2, CH4, and C8H18, which is octane. And the way we calculate it is just to take the number of moles of the carbon times how many times the molar mass of carbon. So in this case, and then divided by the molar mass of the compound. So for CO2, there's only one carbon in CO2, so that's why it's 1 mole here, and multiplied by the molar mass of carbon, which we'll look up in the periodic table, divided by the molar mass of carbon dioxide. So if I plug in the numbers, I have 1 times 12. 12 is about the molar mass of carbon, then 44 is the molar mass of carbon dioxide, so multiply that by 100%, you get 27.2%. For methane, you're going to do 1 mole again times carbon divided by methane in this case. So that would be 1 times 12 over 16. So you get 75% carbon for methane. And then lastly, for octane, now you have 8 carbon, so 8 times 12, divided by the molar mass of octane, which is 114.23 times 100%, giving you 84%. The next question in that lecture note is asking for percent of a substance in a mixture. In this case is xylene in petroleum. So xylene is one of the compounds that you get from oil refineries, and here it says that there is 75.2 grams xylene in 1022 grams petroleum. So to get the percent xylene, all we need to do is take the mass of xylene divided by the mass of the petroleum times 100%, and we get 7.36%. So hopefully that's pretty straightforward.